Hey, everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hello.
And Charles Max Wood from devchat.tv. This week, we have a special guest, and that's Hassan Kane. Hassan, do you want to introduce yourself?
Hey, thanks, and grateful to be here. Yeah, my name is Hassan. I was born and raised in Ivory Coast, West Africa, before moving to the US at the age of 17. Growing up, I was very interested in math and physics and always wanted to do engineering, even though I didn't know what it meant. And I was fortunate to be able to attend MIT, where I was studying CS with a minor in math. And I studied at a time where the field of machine learning was taking off. So it definitely, affected my life trajectory. Fast forward to now, I'm leading the data science team at the startup called Entropy Labs, where we work on natural language processing for customer support. Yeah, so that's
Awesome.
little bit about me.
Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on, it's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course.
Yeah, so you said you started when it was taking off. So what year would you say that you started to get drawn into machine learning? And what was the thing that took off that sort of brought you with it?
Mm-hmm. Yeah, it's a good question. I started my, attending college in 2013. And actually, as soon as in my first class, there were examples. And because I came being interested in math and physics, and they're kind of like two paths for those studying computer science or interested in math and physics. There is one path that's more on the cryptography side. So, talking about encryption and protocols and things like that. Or you have the kind of machine learning side. Even in my introductory computer science class, there were a few examples, but nothing too crazy. Even in the second class, there was actually, that's where it started to get really interesting. We had to program a robot that had to learn to localize itself given a model of the world. So basically it was a very simple simulation of Mars rover, but just in a room where basically the robot would send pulse and laser, and based on the distance to the wall, the robot actually had a map of the world and say, okay, if, in the west direction, I'm that close, the north direction, I'm that close to the wall, and east direction, I'm that close to the wall, this is where I think I am in the map. Or this could be the 3 location where I sample from, and over time, the robot would kind of converge to its location. So it was one of my first time seeing, probability in action and somehow being very helpful. But I would say that one of the tipping point for me was fall 2014 when I attended a healthcare hackathon with a friend. And, at the moment, the app that we started working on, the goal of the project was to basically do skincare issue detection, but from a phone. And what we did at the time was just we would have, that was for a demo. We would just have a picture. We would do reverse image search of the picture on Google Image and say, oh, maybe these are the likelihood of having this skin issue and whatnot. But then over the time, just on that one example from fall 2014, convolutional neural network started really taking off. And I've seen over the years how that problem went from being very almost impossible, where we're literally doing reverse image search, to now becoming more and more feasible. So I would say the tipping point started to be around fall 2014. And I personally decided to really explore the field after summer 2015. And there was this kind of op-ed on deep learning by Hinton, Benjo, and Jan LeCun that said, okay, this is what the field is about, and this is how it's going to change the world. So that was around that time that the seeds were planted, but really when I got to see the powerful application enabled by the rise of deep learning in my third year, that's where I was that sounds amazing. Yeah,
that's super awesome. It is sweeping people up left and right. It's a really cool thing to get involved. Cool things come out, and then more and more people go, wait a second.
Yeah, right.
So a lot of the stuff that I'm seeing in the material you sent us is about natural disasters and helping clean that up. I think there was some stuff on cleaning up the Niger Delta. There was some stuff. It looked like some of the stuff implied like fires and stuff. I actually have a funny story. So I live in Lehi, Utah, which is we're a growing town. We're kind of becoming the tech hub south of Salt Lake City. And anyway, there was a wildfire that was up on the kind of the northeast end of town. And I live all the way out on the west end of town. And so I started getting calls from family members and they're going, are you okay? Is everything okay? And, and I'm like, yeah. They're like, have they evacuated you? And I'm like, no, that fire's nowhere near us. And they're like, the one in Saratoga Springs, it's a little town on my side of Lehi, right? And so it turned out that one was a whole lot closer and had the possibility of actually hitting my house. Wow. And there were two wildfires at the same time. And I just was completely unaware of the one that was closer to me. I mean, they got them both under control. I think they lost like 2 homes out of the whole thing. I mean, it burned acres and acres and acres. But anyway, I'm kind of curious now, since it hits close to home. I mean, how does AI or machine learning, how does that apply to fixing or cleaning up natural disasters? Because, some of your examples were like oil spills, which is also interesting. It's like, yeah, how to use AI to know how to handle that. And then in my case, it's like we've got all this fire-scarred land out here now, right? And it'll come back in a year or two, I'm sure. But yeah, how would it help us here?
Yeah, in that case, I think like one of the underlying technology that powers a lot of this is the rise of remote sensing. So rise of like cheap satellite imagery. So there has been, in the recent years, like rise of providers like Planet Labs and other companies that have put up satellites out there and that can even capture like image of the Earth regularly. And so one of the challenges that come with that is, analyzing all of this change, right? So identifying building, detecting change, and a lot of areas that I got exposed to involve using computer vision. There's like so much that can be done there. On one side, just like classifying land over time, or in other case, even identifying traces of natural disaster, because based on multiple, because with satellite you have not only the RGB like red, green, blue, but you have multiple wavelength. You have infrared, you have thermal image, you have all sorts of things that can be used, to detect not only change, but also those wildfires. So there's been increasing interest in using those tools to do a couple of things. One is kind of detection of these events before even the public or other people are aware of those. So you can think of it as Earth, real-time Earth monitoring. And a lot of organizations NASA or European space agencies are doing that. But over time, there's been an interest to collaborate more with humanitarian communities to provide real-time data in case there is an emergency, such that people can, identify a natural disaster, their progression, and estimate damage in real time, such that they can allocate resource. Because when such disasters strike, time is of the essence. And if you have an automated analysis tool that can say, okay, this was this region yesterday, this is this region today. I noticed, the spread of this fire, or this is a live feed of the area, and I noticed the spread of this fire. I'm gonna learn to predict where the fire will propagate next, or just a disaster is struck in that city, and I can detect, from the image of yesterday, which building seems to be affected, which area seems to be affected, where should we deploy resource? Because in that case, it's normally human analysts that would have to look through that data and, take a few hours, identify the regions. But if you have algorithm that can take, image of before, say yesterday, image of today, we can actually start training algorithms to detect that change and direct resource where needed.
Wow. What do you think is the more popular, this kind of this data collection, right? To feed in and to create these algorithms. I'm seeing several different directions. You were talking about NASA, we're talking about satellites, we're talking about huge, amazing equipment. But also on the same side, I'm seeing people really go down to edge devices for machine learning. Small, I think it was Exnor AI who had the solar powered AI chip that could be picked up by a balloon, and it was so small. I guess in the same sort of vein, are you seeing a trend? Perhaps you were talking about these massive amounts of information and this influx. Is it people like NASA? You said they're working with smaller organizations. Do you think the smaller organizations are getting these more edge level devices? Do you think people are going to start setting up small phones and stuff to help catch fires early? It's just sort of an interesting avenue. It reminds me of the web kind of saying do you do it on the server? Do you do it on the client? Yeah. I feel we're seeing the same thing here in AI.
Yeah, good question. So in those kind of like use case, the advantage of, satellite imagery or remote sensing data is that it's very consistent. And so over time for these like large scale like events, it actually helped to have that consistent data. So that's why for those use case of like change detection, of monitoring like wilder, like forest and things like that, it makes sense to use remote sensing or like satellite imagery because it's consistently collected and we can track change over time. However, you're getting at an interesting point, which is that, the flip side or like the downside of that is that, in some application or some use case, the remote sensing data may be too small. So in some case, you may need to fly like a mini drone with a camera over an area or those things. But you do get into the issue now that the data there may not be as consistent as because, for like a satellite is at a constant altitude over time. So it's very easy to compare the picture of yesterday with the picture of today. But if you now try to fly a drone and, over like a river or over area, you need to make sure that, you're going to fly at the same altitude as yesterday. Otherwise, suddenly those details are going to be a little bit harder to capture, a little bit harder to label. And that's often the challenge of this edge thing, which is that the data gathering may not be consistent. And as a result, can kind of like hamper the ability to use those edge device. But in some other case, like you're correct, because like, the even more extreme version of the edge is actually the person with a smartphone, right? So like people have also, in some of these cases, tried to leverage social media data with people publishing videos or pictures of if there are like incidents that happen to understand how to respond, where to locate. So like social media and like people at the edge can help with that. But the advantage of the, remote sensing is kind of the consistency of that data gathering.
Right. I'm just curious, as you pick up these different changes, how do you know which changes are favorable? Or the goal just to get it back to the way it was? Or is there some other option to use AI to determine, what, this all burned down, but we could actually get some of these, maybe we have an invasive species or something, right? And so we can figure out how to keep that from coming back and bring back, some of the more natural things that live there. Or is that kind of outside of this?
So it's like, one of the biggest challenge with Earth monitoring in general is that like, even if, if you ask kind of like most people, how has the Amazon changed over time, or how has, this like body of water in the Middle East changed over time? Like people cannot even quantify, or like they may not have like the best quantitative estimate. So I think like a lot of the first step come in the support of just like understanding how, like in a very quick way, how some areas are changing over time. I think in many cases, I would say it's the response to those changes that like is of a political nature. And it really depends on many things beyond AI, fortunately, unfortunately. But the first part is helping to quantify and predict change. So I've seen like a lot of work. I mean, and all of this is kind of like emerging. So it's not full-fledged, and it's an area that like I think in the next years or decade will become more relevant. But some of the things can be, could you predict where a region will be affected by, water scarcity and deploy things like ahead of time? Or could you predict which region will be affected by heat waves and like, do a lot of prevention to prevent these disasters to strike and surprise everybody? And we even actually saw that a little bit with the COVID-19, actually, where like it was apparently a robot that detected the first signs of the spread of a pandemic, but it then we also see that it's depending on the political bodies to kind of take that information and act upon it. And that's kind of like where it's, you could say it's one of the limitations of the system is that in that case of monitoring, it just tells you, hey, this is what I think is happening, but whether or not it's good, whether or not how you respond to it is completely different. Actually, there was even recently work by Google X on tracking like marine species actually in the ocean. And they kind of like developed this classifier that can identify different species of fish. And so they would have like these robots going in the ocean and kind of like tracking wildlife and just have an example of like different species. So like there's a lot of like interesting things like that, which are definitely under discuss. And I'm glad that you allow me to kind of like bring this up. But I think that in a lot of cases, the biggest challenge is after you gather that data, like what decisions do you make? Like, let's say you track some wildlife population, you notice that it's increasing or decreasing in an area. Like a lot of the response, like I think it's more towards, political decision makers, for better for worse, but that's kind of like one of the limitations. And another thing, sorry, even on the edge side. So I remember being at a workshop like 2.5 years ago, and there were some researchers from Kenya, and they were talking about actually one of the sides where like it can be helpful for like edge is monitoring birds actually. So there's been some work actually on one monitoring bird population. So what they would have is they would have those edge devices that can actually recognize the sounds of different bird species.
Nice.
They would deploy them in the forest and track over time, how many parrots did we hear or how many like other type of like species did we hear. And that will enable them to collect the data and understand the dynamics of like migration, of like species count, and things like that. So that's where edge actually is helpful, because you're not going to get that from satellite for sure. So yeah.
Actually, I would love, anything sound related. It's going to have to be edge. I'd never thought of it that way before. And I have to say, I've heard some pretty crazy birds in my neighborhood, and I wish there was like, I was like, who do I talk to ask what is that? And it's starting to, we're all getting an expert in our pocket, which is really cool. That's a great application. I wonder if there's anything out there. Like, what bird is this? The app.
There's actually there's currently a challenge on Kaggle around around detecting different sounds of bird. Like they did some effort to label different sounds, but it's true that it's like a whole ocean in itself. And that's actually one of the interesting case, right? Where we as humans don't even know. Like we don't know, right? It's a form of modality that we are not actually used to, and that's where like a machine that can just listen to all different type of species, like a Shazam for bird songs, can actually start to outperform us in a regime that like we're not even very good at, except if you maybe like train to be bird watching. But that would definitely help to have those edge devices. I can say, like what bird is that?
That's so awesome. You mentioned Kaggle, which is a great place for people to come in and learn from experts and also see how well they're doing. I wanted to ask you, you said you came here, I think, how old were you? 17 when you came to the States?
Yeah.
What an awesome story to come to the States and to break into technology and to break into a brand new technology. You obviously, you know the path well. You knew where you wanted to be. There had to have been some serious things that you had to surmount in order to switch countries, learn everything new, and then be at the top of your game with something that most people don't have. So I have a 2-part question for you. One is, what are the tricks that made you do it? Well, what made you specifically capable of kind of getting into it and learning more about this? And then also, what would be your advice to new people who are trying to do the same thing?
Yeah, you're absolutely correct that, when, for example, I like even, I mean, I don't actually say, I didn't have actually a clear idea of like, I mean, I say I wanted to be an engineer